Good morning, everyone. This is G. Vishnumurthy, lecturer in physics, Government Degree College for Women, Vanaparthi. Today, my topic is fiber optics. This is like fiber. So, before we going to topic, what is optical fiber? An optical fiber is an flexible, transparent fiber mode of light quality glass, example silica or plastic, slightly thicker than a human hair. It either functions as a waveguide or light pipe that transmits light between two ends of the fiber or fiber cable. The optical fibers are widely used in fiber optics communications, which permits the transmission over long distances and at a higher bandwidth, that is data rates, than other forms of communications. Fibers are used instead of metal wires because signal travels along them with less loss and are also safe to electromagnetic interference. The field of fibers are used instead of metal wires because the signal travel long distances with less loss and are also safe to electromagnetic interference. The field of applied science and engineering concerned with the design and applications of optical fibers is known as fiber optics. So these are the most important because of in communication systems. If you travel if a signal is travel from such a long distances, in previous years we are using the metal wires. In metal wires, the metals are fabricated with the metallic alloys, so therefore they are affected with the electromagnetic waves, and such signals are lost, so therefore there is no clarity and there is no intensity in the signal, so we got the weakest signals. But in the case of optical fiber, in fiber communication we have less lost signals because it is surrounded with coatings there, so therefore the signals traveling by means of the electromagnetic waves like light waves, so that these optical fibers are used in communications, signal communications. So this is the important in communication signals. And now the history of fiber optics is there. The fiber optics is not really a new technology, it fairly old. So guiding of light by refraction, the principles that makes fiber optics possible, was first demonstrated by daniel Daniel Caledon and Jacques Babinet in Paris in the early 1840s. So these fiber optics are depending upon the light property, one of the light property that is as reflection, but the purely property is total internal reflection. So this is demonstrated in 1840. The scientists are the Daniel Caledon and Jacques Babinet. Now the uses of optical fibers. So fiber optic can accommodate a variety of needs because it is very thin. So it is essential in some variety of needs. So it can be used in communications, fiber optics, sensors, illuminations, and medical purposes. So these are the main important roles in communication systems and fiber optic sensors, illuminations, and medicals. So and also in other places where bright light needs to be shine on target without a clear line of sight path. So these are important. This is important in modern warfare. Another use is used in building to route the signals from the roof to other parts of the buildings, and many more usages. But we will only discuss us use of optical fibers in communication here, because of this is covered in our syllabus. And now in communications, so optical fibers can be used as a medium for telecommunication and computer networking, because it is flexible and can be bundles as cables. So it is especially advantageous for long distances communications, because light propagates through the fiber with little attenuation compared to the electrical cables. So the per channel light signals propagating in the fiber have been modulated at rates as high as 111 gigabytes per second. So that is a very high amount of rate by entity, although 10 or 40 gigabytes is typical. So in June 2013, researchers demonstrated the transmission of 400 gigabytes as over to signal channel. So this heavy amount of signals can be traveled in optical fiber. So that's why the optical fibers are commonly used in communication systems. So therefore we got these fiber optics are used in telecommunications, in like internet facilities and telecommunications. And now the each fiber can carry a many independent channels, each using a different wavelengths of light. As in 2011, the recorded of the bandwidth on a signal core was 101 terabytes per second, that is 370 channels at 273 gigabytes per second each. So in this we will use one cable that have 101 terabytes signal. The core has 101 terabytes signals, and the channels at 273 per second, 273 gigabytes per second. So the record of a multi-core fibers as of January 2013 was 1.05 petabytes per second. This is the high amount of signal carrying. Now the benefits of optical fibers are there for shorter distances applications, such as a network in an office buildings. Fiber optic cabling can save the space in a cable ducts. So this is because a signal fiber standard category Ethernet cabling, which typically runs at 100 megabytes per second or 1 gigabyte per second speed. Fiber is also immune to electrical interference, that is no crosstalk between the signals in different cables and no pickup of environmental noises. So this is the main important. And normal armored fiber cables do not conduct the electrically, which makes the fibers to good solution for protecting the communications equipment in high voltage environments, such as the power generators, facilitators, or metal communications structures prone to lightning strikes. Another one is there, that is that they can also be used in the environments where explosive forms are present without danger of ignition. Structure of fiber optical is there, and optical fiber is a comprised of a light carrying core surrounded by a cladding which traps that light in the core by the principle of the total internal reflection. Most optical fibers are made of glass, although some are made of plastic. The core and the cladding are usually fused silica glass, which is covered by a plastic coating called the buffers or primary buffer coating, which protects the glass fiber from physical damages and moistures. So there are some all plastic fibers used for the specific application. Glass optical fibers are the most common type used in communication applications. In fiber In fiber there are three parts are there. The center part is called as the core, and which is surrounded by the cladding, and the core cladding are surrounded by a plastic protecting shield. So that is called as the primary buffering shield, and another is upon the primary buffering shield, and secondary protecting shield also there. Generally the core and cladding are made with the glass. Sometimes in typical cases the core and cladding are made with the plastic. So in the light is travel in only the core by means of the total internal reflection. The cladding is protecting the light is do not pass throughout the core, and which is maintain the light is traveling in the core. And this is the structure of fiber. And here you see the center point, which is called as the cladding, and it is surrounded by the this is the black dots are called as the cladding, and center one is called as the core. Here you see this is the core and this is the cladding. So here you see the single mode, there is only one path of light is taken take down the cable. Here you see the only one light will be propagated through the core. So that's why this is called as the single mode optical fiber. But here in case of this figure shows multi-mode, because here you see this one is first, and this one is second, and this one is third. So therefore three signals are travel through this optical fiber. So therefore this optical fiber is called as the multi-mode optical fiber. When the signal, only one signal is travel through the optical fiber, then it is called as the single mode optical fiber. Here you see the center part is called as the core, and which is surrounded with the cladding. So those are made with the plastic or silica. But in the case, but always the case is the refractive index of the core is greater than to the refractive index of the cladding. So that's why the total internal reflection takes place in the core. And now here you see the structure of the optical fiber. Here you see the optical fiber contain one core that is represented with this center part, and cladding, this one is cladding, and third one is called as the buffer. It has a 250 micrometers diameter, and the 4 is called as the, which one is 4? So this is called as the jacket. So the 3 and 4 are the protecting shield. So those are protecting from the physical damages of the optical fiber. Now 1 and 2 are most important. The one has the signals which are passed through the core, and the cladding is protecting the signal do not pass away or passed out from the core. So this is the structure of the optical fiber. Now here you see the loss in optical fiber. Sometimes losses are there in the optical fiber in special cases. Loss vary greatly depending upon the type of fiber. Plastic fibers may have the losses of several hundreds dB per kilometer, and graded index multimode glass fibers has the loss of about 2 to 4 dB per kilometer. Single mode fiber has a loss of 0.4 dB per kilometer or less. Here you see there is a external force is applied on the plastic fiber. So therefore due to the pressure the light ray is do not undergo the total internal reflection. So it will be captured by the cladding, and so therefore the signal will be lost due to the external forces. These external forces are reduced by using the protecting shield. Though the protection shield are there, that is the buffer has 250 micrometers diameter, and the jacket is there, that is the 400 micrometer diameter. And now what is the mode of what is it mode? That is the how the fiber will be made. So by using the silica, by using the plastic, by using the fluoride, by using the phosphates. These are the most important materials for making the optical fiber. Now the optical fiber cables are there. In predictable fibers, the cladding is usually coated with a tough resin buffer layer, so which made by a further surrounded by a jacket layer, as usually glass. So these layers add strength to the fiber but do not contribute to the its applicable waveguide propagates. So the protecting shield can protect the from the physical damages, but it cannot involve in the guiding of the signals which are passed through the core. The modern cables come in a wide variety of strengthenings and armor. So designed for applications such as the direct burial in trenches having a high voltage isolations. So submarines, installations and intestines in a paved streets. So sometimes those are used in the submarines and modern warfare are there. So the fiber cables can be very flexible, but traditional fibers loss increases the gradually if the fiber is bent with a radius smaller than around of 30 millimeters. Now the types of optical fibers are there. The last tube cable. Here you see the some important losses tube cable, that is the types of optical fibers are there, and the tight buffered core are there, core is there, that is another one is there. And now the types of optical fiber cables, some are there, that is the core cladding and the plastic fiber, plastic buffer, air gel and the rubber is protected and the surroundings. Next the fiber connectors are there. Some of the fiber connectors I showing in this figure. So these are used in the optical communication. Another one is there. So these are modern techniques are used in the optical communication. Now here you see, so these are called as the more number of optical fibers are there. Each optical fiber containing the 273 channels per second, so 273 gigabytes per second. So these are connecting to country. So because of every country is connected with the internet, so this internet is completely depending upon the fiber communications. So the fibers are guiding the lot of signals per second. That's why so we are using the fibers in telecommunication as well as network communications. So system is there, that is the transistor, the electrical connector is there. Now the optical port is there, this is the optical port, and the optical connector, this is connected to the transistor. And here you see the orange color tube is called as the fiber optic cable, and it has the optical connector again. So the fiber optic cable containing the two sides of the optical connectors. So those are connected, one is connected to the transducer, and that is the electrical connector, and second one is connected to the transistor, that is the optical port and electrical connectors. So now here you see, so that the core cladding and jacket is there. So here is there, the signal source is there, and signal source is transferred to the optical transmission by using the copper cable, and the optical transmitter is transmit the signal by means of the fiber optical cable, and the fiber optical cable is guiding the signal, and the optical receiver is there. So optical receiver is receiving the signal from the optical fiber and is transfer the signal into signal destination by means of the copper cables. So this is the communication system which is used in the optical fiber. And now the advantages of optical fiber over the conventional copper system, that is the first one is broad bandwidth. We are already mentioned here it guided the lot of signals, so that the bandwidth of the signal is very high to comparing the copper system. And now the electrical insulators are there. So the plastic is insulating. So optical fibers are like as and second one is third one is immunity to electromagnetic interference. The optical fibers is electrically non-conductive, so it does not act as an antenna to pick up the electromagnetic signals which may be present nearby. And now the low attenuation lasts over the long distances. In copper systems, when the signal is travel from one place to another place such a long distances, there is a much more loss in the signal. But in the case of optical fiber communication, the loss of signal strength is very less, and the lack of constrictly metal conductors. So these are all the metal conductors are there, and the optical fibers are using in fishing in a sea, or the optical fibers are making one country to another country. So in between there is a sea. So by means of this, so optical communication system is making. So these are the optical fiber communication between one country to another country. So this is called as the optical fiber communications, which connecting the one country to another country. Thank you very much.